Hello, sir. Hello, sir. Uh, a very good evening to everyone. I'm Nitish, AML department, fifth semester. So, today in Pragati webinar, we are going to see a topic on data structures and applications in C. So, why this topic has been chosen, or why this topic has a vital place, why we need to take the topic as a data structures or its application. Because as a computer engineering or computer science based engineers, we need to be more precise on data structures and how to we use the data structures, because they're one of the main thing which we can get it as input to function it all other things. So the arrangement of data or the things whatever we can do with the data can be uh, a great thing to know. So as a data structure, we are going to see the uh, data structure. So let me start with the basic definition of the data structures. So as the definition of the data structure is a storage that it is used to store and organize the data. Means the data which is given or data which has to be processed for our application purpose, whether it is for a system purpose, OS purpose, the data has to be organized and it has to be stored on a certain criteria. Only if it is done, we can do it on the for the use. So the data structure is which we use to make organize and store the data. So it is a way of arranging data on a computer so that it can be accessed and updated efficiently. So if suppose the data are not placed or stored according to the some criterias and all, if we will we will trap in a situation that we will not get a perfect sequence or perfect fetching of the data whenever we need to work on that. So data structure makes it to simple while organizing that data and storing that data. So a data structure is not only used for the organizing the data, it is also used for processing, retrieving, and storing the data. Means data structure is not only making the data to be stored in a sequence, it's like we are going to use or we are going to make some more applications or the operations, whichever data structures we can apply in our computer science background. So, so let's coming to there may be a basic and advanced type of data structures are available in nowadays as a software system build or system software system developed as far away from the traditional to now advanced method. So data has been evolved from the tradition to the advanced level. So next, we will see why the data or why the need of the data structures. Let's see some of the examples. Like first one is the databases. Databases use data structures to store and organize the data. As we told in the first definition of the data structures itself, databases are those the containers. We can say it's as the containing blocks where the data has encrypted based on the sum of the criteria. So second one is operating system. So operating system is the backbone of every system or computer application. Whenever operating system has to manage some process or anything else, it's going to use the data structures such as stack and queue. And also operating system, the main thing is the queues. Mainly, if suppose one of the two processes are going to execute from one by one at a time, what happens is and the second queue or second process will be encrypted to the queue as it has to execute after the first process. So such applications has been used in the operating system also. Third one is compilers. So compilers use data structures to represent the structure of the programs, how the structures are used. Like in, we can say in Spider, we can just see how the execution of the program is done using the stacks. Means the step-by-step code or the step-by-step process of executing a program, we can see by the compilers. Web browsers, like the data structures mainly use like if suppose HTML, CSS, JavaScript has been used in the web browser creation, now obviously it will use the data structures to store. So data structures are an essential part of in computer science. If a computer science background student must know the data structure concept with a clear cut because it has been evolved for the so many applications that we are going to develop in the computer science field. So let's see how the data structures is classified. So mainly we can say this data structure is classified into two. One is linear data structure and non-linear data structures. So the linear data structure again classified into static data structures and the dynamic data structure. Under static data structures, array is the example. Dynamic data structures, queues, stacks, and linked lists are the examples. Let's see the nonlinear data structures. In nonlinear data structures, it's a more complex uh, field of data structure. We can say like the examples like tree and graph are being more complex other than the data structures that have been described like array, queue, stack, and linked list. So let's see one by one. So the linear data structure which in which the data elements are arranged sequentially. Like the name suggests, we are going to store or organize the data in a linear form. So this makes like one of the if suppose one element, suppose let's say 1, 2, 3, 4, 5. These five data has to be encrypted in or sequenced in a form of data structures. On this time, we will take the example of array. In array, it does is one after the other of the same type. We are going to organize the data. Means after one, we will encrypt two. After that, we will store 3, 4, 5. So you can see a sequence. So that as the name suggests, it is the linear ordering of the data. In that, we have two things like static data structures and dynamic data structures. Static data structures means there will be a fixed memory size. After that memory size, we cannot add or we cannot organize the data more. So the real example or the one of the data structure is the array. Second one is dynamic data structure. In dynamic data structure, the size is not fixed, and also we can update anytime. Like the examples are like queue, stack, and etc. So mainly stack and queues, like as the dynamic data structures are more concerned about the memory complexity or space complexity, which does to make so many efficient way of organizing the data under the dynamic data structure. So next is nonlinear data structures. Nonlinear data structures which sequentially or linearly cannot be placed means one after the other we can not store the data. So we can say an example like trees and graph. So in the trees, what does happens is in tree we are not going to make the data to be organized in a sequential way. In three, we are going to make from one parent, two child or three child, however child. After that, we are going to deal with a parent-child relationship. Under that, we are going to organize the data and store the data. So the examples of nonlinear data structure is trees and graph. So today's class, we are going to discuss the two data structures, that is arrays and stacks. As these concepts are more big to or large to explain, we are going to see the array data structure and its operations, and also the stack details and also its operations. So first, let's see the array data structures. So in the figure also, you can see, in this figure itself, you can see a sequential blocks of memory can be seen where the array elements are stored. And also, each blocks is assigned to a number from 0 to 5. So, these from 0 to 5, the numberings from 0 to 5 are called as array indexing, or like individual things are called as array index. Means whenever one element is going to placed in a block, there will be an index for that element. And also, like the data like 2, 4, 10, 5, 15, 3, these are the array elements. So array data structure is the collection of items stored at the contiguous memory locations. The idea is to store multiple items of the same type together. Means array means the same type of data. Suppose I am going to upload or store the data in the terms of integer. Means like I am going to store 1, 2, 3, 4, 5, 6, like this. These all are categorized under the integer type. So I need to store these data structures in my memory, like it need to be sequentially ordered. Then I can choose the array data structure. So one thing has to be noted is array can store the data types of the same type. Means same type data can be stored in the array. So because of the same type together, it can actually calculate the position of each element by simply adding an offset to the base value. Suppose one value can be assigned to the first memory of this array. After that, every address of every other blocks can be accessed by, we are going to add the bytes of one. Suppose I'm going to take integer means number of bytes that integer has used. So second one is base value plus the byte value. So like that, I can predict the address of the other variables also. So next, we are going to deal with the search, insert, and deleting sorted array, that is array operations. How we are going to do the operations in the array. So in the figure, you can see first one is the search operation. Operation thus means search operation thus means I need to find out a data that is in the that is available in the array that I am stored. So in that, suppose I am going to the in the figure you can see, I need to find out whether the element 3 is there or not in the array. So in the figure you can see in the data structure, that is array, you can see the element 3. So I need to check whether 3 is there on that array or not. So for that, we have a code. So let's see how to insert in a how to search. Let's first go with the search. So how to search? Is there any alternative way to search in an array? Yes, we can search using the binary search. Binary search is one of the most used, and also it has a vital role in the computer science field as it is to be more important one program. So in binary search, we can use the array concept to find out the element in that array. So let's complete these uh, definitions of these operations. After that, we will go through the practical session. So next is how to insert in a sorted array. So in an array, how I can sort an array means how insert an element in an sorted array. Suppose one original array is there in the figure you can see. So 3 is the figure, 3 is the element has to be inserted, but 3 is not there in the original array. Suppose I need to, in a sorted array means I need to insert such a way that after the operation, it has to be in a sorted way. So I need to add these elements, 3 elements between 2 and 4. So for that, I need to check the index where I need to be insert the element. After updating that index, I'm going to increase one size, and after that, I'm going to insert an element 3. So this is how an insert operation does. So next is delete operation. So let's see how the delete operation works. In the delete operation, I need to delete on an array. Like we will take the same example which we got at the output in the uh, last stage. Let's see, we want to delete the three element. If we are going to delete the three, we have to take the three elements from the array. After that, we need to shift all other elements after three, which is in the original array. Means 4, 5, 6 has to shift it to the third place, and 5 has to shift it for the fourth place. 6 has to fix for the fifth place. So this is the thing which we need to do. So on that time, we need to delete 3 and also update the size of the array. So this is how the delete operation does. So let's see how this works. So let's see how this works. So I think all you can see my Visual Studio uh, page. So let's get in with the array search first. So array search is just we are going to implement, or we are going to do the binary search implementation to find out whether that element is there or not. So let's see in the code you can see here. Uh, First, I'm going to create an array. That is in my array, the data are 5, 6, 7, 8, 9, and 10. Uh, after that, I'm going to after that I'm going to let me show you. Then after I'm going to 1 minute. Okay. So my thing is like I need to have a key element that is 10 means 10 has to be searched in the data. So what I'm going to do is I'm going to pass the function. I'm going to call the function binary search in which I'm going to pass the int in the code. I will just 1 minute. So what I need to do is I'm going to pass the element that is the array which I need to process, and also I'm going to pass the low means in binary search we are going to divide the size of the array, and also we are going to search in the right and also left of the array. So I need to pass the low limit and high limit of the that array, and also the key element which I need to be searched. So suppose if the right side means the key is low means if the key is middle of that array, then give the middle element as the search one. If suppose not, then I need to search again after the middle means right of the middle. Else I'm going to search in the right of the middle. Suppose I'm going to search here. Let me search. I'm going to run the program. So suppose I'm going to run this code. So my key value is 10. So, so here you can see at index 5, the element has 5 now. Means in the output bar, you can see here at index 5, I have obtained the key value. So this is how the search does. Next, we will see the insert operation. In insert operation, in insert operation, what we are going to do is we will have one array, set of array. I need to pass one element. Suppose I'm going to pass the element 26. How I should enter it? First, I need to I will display the element which we need to be before the insertion of that element. I'm going to uh, display the original array. So if I display that, the original array will contain 12, 16, 20, 40, 50, and 70. After that, what this happens is, suppose I'm going to call the function which I'm depicted for the insertion. On that time, what this happens is, so I need to pass the functions like I need to pass the array and I need to pass the size of that array and I need to pass the key element which I need to be inserted in the array and also the capacity how much can the array can be stored. So on that, if suppose the capacity is exceeded, if suppose the capacity exceeds means I need to return that the insertion cannot be happened. Else, what I need to do, I need to insert the element within that index, and also I need to make a more size. One more size has to be there. And also I need to shift where I have inserted that element. From there, I need to shift the element one by one to right side. So this is just happens in the insert operation. Suppose I'm going to run this code. So if I run this code in the, you can see 12, 16, 20, 26, 40, 50, and 70. So here you can see at the middle, 26 has been inserted. This is how the insertion operation does in the array. So let's see the delete operation. So whenever I'm going to delete, what I need to do, same logic, but here I need to make that element to be extracted and make a shift from the right side to left side from where it is deleted. So same thing I'm going to do. So here I'm going to use the concept of binary search to make understand whether this element has been there. So I'm going to take, let me see the main program. So I'm going to pass the array and also I'm going to how much size can be adopted in that array. And also the key element has to deleted is 30. So I'm going to pass this. When I give a pass, first it will search for the deleted option. In this deleted option, I will deleted function. We will go to the delete function. Here, for the position which I need to be deleted can be find out by the binary search. What does binary search does is it find out where this exact index is there. So this index will be returned to the delete element function. From here, where this delete has been there the function, the for loop till where that position comes, we will delete that. And after that, we are going to shift. That expression can be seen in the a array of I is equal to array of I plus 1. Means I'm going to shift the right side elements after deletion to the left side. So let's see. So the operations of array has been completed. So we have discussed only the sorted arrays. There can be unsorted arrays or complex arrays or 2D arrays. Some changes on these programs has to be changed. So let's get in with the stack. Means the second data structure we are going to use. So in the stack, how does the stack or what do you mean by the stack really it is? Stack is one of the data structure. So stack you can in the figure also you can see stack is like a container where we can enter the element or we can dump the element and also we can retrieve the element. But other than the array, here we have some of the principles to be observed on the stack. So the first, let's see the definition. So you can see stack is a linear data structure that follows a particular order in which the operations are performed. Means the LIFO concept. Insert it will be the first element to out of the stack. Suppose I am going to enter an element at the last means that element has higher most priority to escape or retrieve from the stack. This is the principle behind the stack. So here, mainly in stack, we have basic operations like push, pop, top, is empty, size. Whenever I'm going to enter an element into the stack, it means that it is a push operation. Whenever I'm going to use or remove an element from the stack, it does the pop operation. So push means we are going to insert an element into the stack. Pop means we are going to remove an element from the stack. Top means the top function will return the top element of the stack. Is empty returns where if the stack is empty, it will show the true, means it will return true, else it will return the false. Size function will retrieve the size of the stack, how much it can store. So this is what the stack operations. So let's see one by one. In stack operation, the first thing is push. So as I mentioned, the above element, first element, which or the top of that element is considered as the top element in the data structures. Means the first last element which has been included in the stack is considered as the top of the stack. So push means I have already mentioned adds an item to the stack. If the stack is full, then it's said to be an overflow condition. So this is one of the technical term which related to the push operation. Whenever we are going to insert an element, we need to check whether the condition is an overflow or an underflow. Suppose it is an overflow, then we cannot insert an element in that. So let's see the algorithm for this. So begin. If the stack is full, return false means overflow condition. You return the overflow condition. Else, increment the top means I need to increment a top. Means suppose the top is I means I need to increment it to I plus 1. Then assign at the top the value which need to be inserted. Then make that top, element as to the top. So after that, if suppose the operation is not done, then the end procedure. This is the algorithm for push operation. Let's see how the pop operation does. So the pop operation does that whenever I need to uh, delete an element from the stack, means it suggests I need to check the underflow condition. Whether the stack is empty means underflow condition will attain. If the if it is not an underflow condition, then you can delete the element from the stack. So if you are going to delete an element, you are going to delete the element from the top. Means as I mentioned, the last element which is inserted in the stack will be getting out of the stack first. So whenever I am going to delete that element, I need to decrement the top, and also I need to assign the decremented value of that stack. This is how the pop operation does. So let's see how this pop operation does. So we will see a function, menu-driven program for this. So in this, I'm going to have perform some of the operations like we are going to push, pop, we have to display, and these things has to be done. So first I need to mention the size of the stack, that is 4. And also the input array I have globally described or globally made declaration on in the program. So in the main program, you can see I have printed perform operations on the stack. First option is push, second is pop, third is show, fourth is end. And I have a choice which I need to make. So in the switch case, I'm going to pass uh, the calls, function calls, which has to be executed. And at so let's go through one by one. So void push. Here you can see whenever the top is filled, means the condition which has to be mentioned for the overflow condition is if top is equal to size minus 1. The size minus 1 is to index of an stack will be from 0 to 3. Suppose it is the size is 4 means this index will be 0 to 4. So the top, suppose it is 3 means Suppose the size -1, that is 4 minus 1 is 3, then it is an overflow condition. So we cannot add more elements on that stack. Else we need to add the element. So what does happens is here you can see it's only one line logic. Top is equal to top plus 1 means whatever top you have right now, it will change to the top. And also assign this top the element whichever you are going to enter. Top element. If suppose top is equal to -1 means here you can see as I said the stack size is like if top is equal to -1 means it is an underflow condition. Whenever underflow condition happens means we cannot add or we cannot delete or retrieve the elements from the stack. So what I am going to do is if suppose top is equal to -1 then display it as the underflow condition. Next the popped element is like input array just like the top element which is there in the stack, I need to display it. And after that, decrement the top from by 1 and make that element to be the top. This is the logic of the pop element. And third is the uh, display. How you can display the same underflow condition has to be displayed because if the stack is doesn't contain any element means we cannot display any other elements. So just make that top is equal to -1 means underflow condition. Else what you need to do is from using a for loop from top to the bottom of the stack, just print out the data has there in the stack. This is how the logic of the program does. So I will run this code. So here you can see the operations on the stack which has to be done. Like first operation is the push operation, second is pop, third is show, and fourth is end the operation or the menu driven program. So I'm going to use the first choice has to be displayed. So I'm going to use the first. Let me see first. So enter the element to be added on the stack. So here you can see the stack is not filled. So I can add the. So I'm going to add 3. Now I need to show this. So use the 3. So in the element or stack, you have 3. Now again, I'm going to delete this element. So you can see if I'm going to display this, means here you can see that the stack doesn't contain anything, means underflow condition has been displayed. So this is how the stack operation does. Okay. So next we will see one of the major application which is used to if we are going to discuss the stack means it's must to discuss how does uh, this work. The application which is of the stack that is infix to postfix or postfix expression evaluation. In is in there in the third semester also. Whatever we are going to study, mainly it is focused on the infix to postfix. So infix to postfix has been one of the greatest uh, application of the stack operations. So, so how to convert the infix to postfix expression using the stack? Let's see that in the next. So first, we will need to discuss about the infix expression. Infix expression is in the format like a between that two variables between there you have an operator. So this is like example is a plus b. This is an infix expression. Second one is postfix expression. Postfix expression, as the name suggests, after the operands, the operator is a obtained means AB plus. Suppose the A plus B can be converted into a postfix expression like AB plus. So here what does happens is, so here we have the input. Suppose we have parenthesized input. So what does the output is? You can see AB plus CDE slash star minus F plus. So if suppose I'm going to use this as the input means I will get the output after converting infix to postfix. So manually we need to do using the stacks, and also we need to check the precedence, how the operators has been uh, have the precedence on from one another to another. So let's see with the examples. So why does it's more concerned to convert an expression to the postfix representation? Why does it seems to be a need? Why it is most need thing has to be done on the stack application? Because the compiler which we have, like it scans the expression from left to right or left to right to left. So because how this the compiler wants to make this thing, or compiler is designed such as it is going to evaluate the postfix expression, because as much as it is going to use by the infix expression, we can predict precisely use the postfix representation to find out the value or evaluating an expression. That's why we are more concerned about the postfix representation. Okay, so this is the basic need why we need to do the postfix representation. See the been discussed. Let me take an example like a plus b star c plus d. So, uh, so first the I value is a 0. So you can see first step I is equal to 0. So the expression which I am going to scan from left to right, first one is a. So it is an operand, means it's not an operator, it's an operand. So I'm going to directly dump it to the postfix expression. So a is an operand, add it in the postfix expression. Next, we have the second step. Here, the I value increments, that is I is equal to 1. So the expression is plus. So it is an operator. What does when the stack? So push this into the stack. So and also the postfix contains a, whichever operand in the previous step, and stack it thus contains the plus element. So the stack is empty. Push plus into the stack. The third step, now I is incremented to 2. The scanned expression is B, it's an operand. So directly dump it to the postfix expression. So before it was A, now it is AB. So the stack contains plus. Okay. So next, fourth step, now increment the I value, that is 3 plus 1. So now the scanned operator, it's an operator, that is star, multiplication. So now the postfix contains the same, that is AB. Suppose you can see the star has a higher precedence than the plus. Okay, star has the higher precedence than the plus. Now for that you need to push the star into the stack. Okay. Next step, in the fifth step, increment I, that is 4. The expression is C, that is an operand. So add this in the postfix expression, that is postfix is A, B, C. Before it was A, B, and it is A, B, C. Now we have in the stack that is plus and star. Star is the top of the stack. The sixth step, now the fifth element is the expression which I am to scan is a plus. So now you can see the stack top has higher precedence than the plus. Means whenever I'm going to add the operator plus in the step 6, the precedence element, that is star, has to be eliminated from the stack. This is the algorithm where it works. Okay, so I'm going to uh, delete or retrieve the star from the stack, and I'm going to display it on the postfix expression. That is ABC star. Now you can see, but the scanned operator is a plus. So the plus is already there in the stack, which have the same precedence. If it is has the same precedence also, I need to jump into the postfix expression. So now the postfix expression will be ABC star plus. So plus and stack top has the same precedence. So I'm going to change this on the postfix expression. Now again, you know, now you can see uh, now again you need to push a plus which has been scanned from there. So now you can see the stack is empty. So I need to insert it into the stack. So what will be the postfix expression will be ABC star plus, and inside the stack there will be a plus. Now in the step 7, we have an operand that is G. So directly dump into the postfix expression. That's A, B, C star plus B. In the stack, we have the plus operator. The final step, there is no element left in the expression. So just dump the data there uh, in the plus means in the stack to the postfix expression from one by one. So here in the stack we have only plus operator. So just dump it to the postfix expression. So the postfix expression will be A, B, C star plus D plus C star. So let me see in the program view. So here we have the infix to postfix. Okay. So infix to postfix, you can see I'm going to have the priority one, precedence one. So this is the main part of the program has to be explained. So here you can see if the operator is a square or raised to means it has the higher most priority. So it has to execute. If suppose the second priority is like division or multiplication, then it has the second precedence. If suppose the plus and minus has came, means you have the precedence after the multiplication. That is third. So if suppose any else is coming, just return minus. This is the logic where this the operator precedence has to be executed. So next we will pass this the expression. So here I am taking the expression A plus B star bracket C plus B star E bracket plus F. This is the string or expression I'm going to pass in the program. Suppose if I run this code, so just hold on 1 second. Suppose I'm going to start running this thing. Here you can see A, B, C, D, E star plus F plus. This is the postfix expression which I am going to get after the conversion from infix to postfix. This is how the uh, expression does change. Okay, so as I told, we have come to an end to the topic as it's a long subject. So we cannot completely do the every data structures in precise time. We need more time. So as per today, I'm going to conclude the my presentation. So if anything doubts does anyone have, you can approach in through the voice chat, live chat. So so any questions you guys have, just pin it on live chat. And also, I need to uh, uh, thank our department, AML department, who are organizing Pragati webinar on every day, which will enhance the student activities on the association field also, and also the AML department. And also, I request all other students to be participate in the Pragati webinar on next days. And also, I wish everyone to be uh, a good evening and also good night. So I wish, and I also thank everyone who joined and have shared your comments on live chat. So thank you, everyone. Thank you.